Remember, it's important to always review the charts you intend to use for a given instrument flight. Planning and preparation before taking off will make you a safer and more competent instrument pilot. Standard Instrument Approach Procedures, or IAPs, allow you to safely descend by instrument reference from the en route structure to a point near the runway where a landing may be made visually. It outlines the criteria used to develop instrument approach procedures. Before beginning, it should be noted that Jeppesen does not create the criteria or devise the procedures for an approach. This is done by the governing authority in each country. Years ago, Jeppesen introduced a new chart format. It was tested and evaluated by human factors professionals, airline crews, and general aviation pilots. The new chart format is known as the Jeppesen Briefing Strip format. This program concentrates on the briefing strip format. The briefing strip approach chart format is divided into 4 sections: heading, plan view, profile view, and landing minimums. The information is arranged in a specific pattern based on how pilots review and use the chart data. Let's take a closer look at the heading portion of the chart. The information on the chart flows from right to left. On the top right side, you will find the location of the airport by city and state. All Jeppesen civil approach charts are filed alphabetically by city name within the state. The city name is shown in bold print for easy recognition. The specific procedure is noted below the city name. The name of the procedure identifies the type of approach and the primary navigation aid upon which the approach is based. It does not indicate the equipment required to fly the entire approach. It merely indicates the equipment needed to fly the final approach segment. If NDB is listed as a part of the procedure, such as it is here, NDB equipment in operating condition is required to be installed in your aircraft in order to fly the final approach segment. In the case of a VOR DME approach, you would need VOR and DME equipment. However, if the approach is titled VOR DME or GPS, either VOR DME or GPS equipment can be used to fly the approach. Both are not required. If the approach course is not aligned within 30 degrees of the runway, the approach is identified with a letter. Notice that this approach is called the VOR DME or GPS-A approach. A circle to land maneuver is required to align the aircraft with the runway. The series of numbers in the center of the chart is the index number. It helps you file the chart and identify certain features. The first digit identifies the airport within a city based on an arbitrary number assigned to each airport. The second digit represents the type of approach chart and is based on the navigational aid used to conduct the approach. In this example, the number 1 represents an ILS, MLS, LOC, or SDF approach. Typically, approaches with the lowest landing minimums and greatest precision have a lower index number than approaches with higher minimums. The chart legend lists the assigned numbers for each type of chart. The third digit represents the filing order of charts that are of the same navigational type. The number 1 shown here indicates this is the first ILS approach chart for DFW. The next ILS approach chart for the same airport would be listed as number 2. The revision and effective dates are also found in the center of the chart heading. Never use a chart before the effective date. If there is no effective date, the chart is for use upon receipt. On the far left side of the chart is the 4-letter ICAO identifier for the specific airport. In this case, KDFW is the ICAO identifier for Dallas-Fort Worth International Airport. The next few rows of the heading section contain information about the approach. This includes communications, pre-approach briefing information, and MSA information. From left to right, the communications section provides the frequencies in order of arrival, such as ATIS arrival, approach, tower, and ground control frequencies. Multiple frequencies may be given for a particular facility, such as the tower frequency here at DFW. In this case, the frequency depends upon whether your arrival is from the east or the west. Also be aware of any notes or symbols in the communications row. For example, the Redbird Tower and ground frequencies do not operate continuously, as noted by the asterisk. In addition, when the tower is not in operation, you are advised to use the Common Traffic Advisory Frequency, or CTAF. In this case, the CTAF frequency is the same as the tower frequency. In select locations where a Flight Service Station, or FSS, is located on the field and can provide local airport advisories, this information is noted on the chart as it is here in Jackson, Tennessee. The second row of boxed information is designed to provide you with a quick reference of the pertinent approach-related information. From left to right, you see the primary nav aid and its frequency and identifier. At DFW, the localizer is the primary nav aid. Its identifier is ILWN, and the frequency is 109.5. Next is the final approach course. In this case, the final approach course for the ILS runway 13 right at DFW is 133. Next is the key altitude information. For a precision approach, this is the glide slope outer marker altitude. For example, the glide slope altitude at Good, the outer marker, is 2,235 feet MSL. For a non-precision approach, it is the minimum altitude at the final approach fix. Following the glide slope information is the lowest decision altitude, DA, or minimum descent altitude, MDA, depending on the approach type. The ILS decision altitude is 791 feet. Also included in the pre-approach briefing information is the airport elevation and the touchdown zone elevation. Below this row of information is a textual description of the missed approach procedure. On this particular approach, the procedure requires a climb to 1,000 feet, then a climbing right turn to 5,000 feet outbound via the TTT or Maverick VOR on the 275-degree radial to the slot intersection. Slot intersection is 35.6 DME from Maverick. Any notes that are applicable to the approach, such as altimeter setting or equipment requirements, are included below the missed approach information. In this case, radar is required for this approach. The minimum safe altitude, or MSA, is located to the right of the pre-approach briefing information. The altitude shown in each sector provides a minimum of 1,000 feet of obstacle clearance within a 25 nautical mile radius of the navigation facility. The name of the facility is listed below the circle. MSA altitudes are intended only as emergency information. Normally, the MSA is based on the primary nav aid on which the IAP is based. For RNAV and GPS approaches, however, the MSA is based on the runway waypoint, airport waypoint, or the missed approach waypoint. It is important to note, however, that if the primary navigation facility for the approach does not provide full azimuth reference information, such as an ILS, the minimum safe altitude is based on the primary omnidirectional facility in the area. The MSA circle may be broken into individual sectors of no less than 90 degrees each. Notice that the sectors are formed by magnetic bearings to the station. In this example, the north sector is formed between the 090 and 270 degree bearings to the Maverick VOR.